This is take home 4, Excel version task number 3, picking up where we left off here. First up, we need a 2x6 table of counts. We got to have the candy color. So let's start with the candy type here. M&Ms, Smarties, and then the colors. Colors are not quite the same for both of them. So we got to make a second set of colors here. All right, now we can do the counting. Our criteria here is going to go from A2. I need to pin that in to the 2. Otherwise, when I drag it down, it's not going to work. A2, oops, that was wrong. A2 to A200. Pin that to column 2. Set your criteria equal to that label there. And it can count those. Similarly, it can count all the other M&Ms and all of the Smarties. And that creates that table, which I'm going to color blue. We need some marginal totals here, so I'll need the sum horizontally. All of those. Also need to sum vertically all of those. And we can check and make sure that these sums match the same sums we had earlier so that we haven't lost any candies along the way. All right. Create a two-way table of proportions to match the table from there. All right, so let's see if we can do the table of proportions here. We just take these values, put them over here, and we're just going to take that divided by that. So it should do all those proportions, and likewise, we can be able to copy that formula over here, get those proportions. Just to check, let's go ahead and sum those up and make sure the sum is 1 so that we've got everything. All right, so those are the proportions. Okay, next up, does it appear that the population appears to be homogeneous? Explain, provide a graph. All right, well, we'll make a graph first before we start explaining. So let's go ahead and take these proportions here and make ourselves a nice little chart of those proportions. And get some better labels on it. Let's see, series 1 should actually be labeled M&M. And series 2 should be labeled Smarty. Oops, something happened there. That didn't work. Try that again. Series 1 should be labeled M&M. And the axis labels should be the colors. Okay. All right. So now we're supposed to make some sort of comment about this distribution. Like, in essence, do we believe that the distributions of these are homogeneous, are the same, or is there some reason when you look at these graphs or these numbers up here and say that they're not the same? So I'm going to say these two distributions look, can't spell, but I'll let you finish that statement, telling me what you see when you look at this graph, what it means to you. Okay, next up, I need a table. No, I need to start my test here. Okay, but I have to check to see if it meets conditions, all right? So what are the conditions for the test? Well, the conditions for the test require certain statements about these counts. That is, these counts here, there's only a certain number of them that can be below 5, and all the rest of them need to be above 5. But in my particular case, all counts are greater than 5, so I can say all counts are over 5, so the test is accurate. Okay. Now we're on to doing the test. So I need a null hypothesis. HO. So here is where you're going to put in what you believe the null hypothesis to be. Similarly, you're going to do the same thing for an alternate hypothesis. You're going to talk about the significance again, as you did before. Okay. So in all of these, you have to tell me what your hypothesis is, and then next to that, you're going to tell me what that means. So state the hypothesis, state what it means. State the significance, state what it means. But I'm going to let you fill all that in. You can do that. Create a table of expected counts, all right? So let's do that part. Let's see, so we need some labels here. Smarty. So expected value. Expected value is going to include this column total, where we keep the 41 fixed, divided by this row total, where we keep the H fixed, divided by the overall total, which is just plain fixed. So that gives us an expected value and an expected value there. So there's our expected table. We also need contributions to the test statistic. So that means we need to take the observed count minus the expected count squared divided by the expected count. We notice that in some cases we don't get much contribution. But in other cases, we get a fair bit of contribution. These numbers are the numbers that are least likely to be what we expected them. So this 6, this 4, this 3, this 2, those are the big areas of difference. Whereas in orange and yellow and green and brown, not much different than what expected, but quite a bit different in the blue-purple area and the red area. Okay, so our test statistic then will just be the sum of all of these parts here. The degrees of freedom will be calculated by the number of rows here. 6 rows minus 1 times the number of columns, 2 minus 1, giving us the degrees of freedom. Then we can calculate the p-value according to the chi-square distribution. Based on this particular test statistic with this number of degrees of freedom. And that gives us our p-value. And then finally, at this point, you will now give your full conclusion again. So in this space down here, you'll be typing up whatever conclusion you can come up with based on the p-value for your test. And again, remember that it should be in context when you finish it, so make sure you do that. And that concludes this video.